Hey, Esher, can you turn off the light, please? Can you turn off the light? Thanks, sir. Okay, so when I'm looking at this, if we look at the cost of pizza, what type of data is this if they're not connected? What's that called? Rahat? What's that called? It is called discrete data. Okay. So I'm just repeating this so that we remember. So discrete data is when we don't connect the points. And the reason why we would call this discrete data, what's the thing stopping us from connecting the points? Look at your table of values. What are the two things that we're looking at? We're looking at cost. Can I have parts of a cost? Like, can I have $50? Yes. Yes, I can. But the other part is number of toppings. Can I have half of a topping? No. So that's why it's discrete data. Like, you can say, hey, put cheese on half my pizza, but they're still going to charge you for cheese. So the data is discrete here, so we're not going to connect those points. Okay. So now we're going to look at patterns. They say that patterns are the hardest things for us to see and identify clearly, but I tend to disagree. Okay, so let's look at that table of data. What do you see as a pattern? I'll take any of them. Rahat?
For the cost or dependent values, we can see that it increases by 0.75 every time.
Right, so every time we're going up here, we're adding 75 cents every time. So every time we're going up and up and up by 75 cents. Are you almost done with the Tim Hortons? Yeah, we're almost done. Okay, awesome. All I can hear is the clankety clank of the Tim Hortons cup. I know you're trying to be quiet, and I appreciate that. What else? So what do you notice about that table? What's happening to the toppings? These are going up by 75 cents. What's happening over here? What's happening to the toppings? At 0 toppings, it's a $12 pizza. So a cheese pizza is going to cost us 12 bucks. If we add a topping to it, one type of topping, we're going to be at $12.75. Then when we go up to 2 toppings, we go up to $13.50. So what do you guys notice? Rahat Pachanda. Anybody? Yeah. Nice. Okay, so what we notice is that these are going up by 1s. So we're adding 1 each time here. And what you deduced from that was every time we add a topping, we're going to add an additional 75 cents. Perfect. Awesome. And what does that result in when we look at this? Is this linear data? Is that in a straight line? Yeah, it is. Are they connected? No, but that's because of the type of things that we're measuring here. But if I were to lay a ruler over it, does that follow a straight line? Yes, it does. So this is linear data as well. Okay, so here we go. Let's write a rule for the data, or a rule for the pattern that we found. So you said that every topping is 75 cents, right, Chelsea? You said every topping is 75 cents. So how can we make that mathematically? I can say it in words. Every topping, 75 cents. How do I do that mathematically?
Every time the x value goes up by 1, the y value goes up by 0.75.
Okay. Yep. But how do I put that as an equation? Because we want it to be a mathematical equation so that we can connect things together. So we can say it in words, and I think we all know what to do mathematically in words. If there's 3 toppings, each topping is how much? 75 cents, right? Each topping is 75 cents. Rahat.
X times 75 divided by 1
Go again, say it again.
Okay, so we
Hang
have
on. No, I don't need the explanation, just say the statement again.
X times 75
When does the
divided.
0.75?
Oh, by 75, okay, I'm with
yeah,
you.
X times 75 divided by 100 is the whole thing, yeah?
Okay,
And then we add 12 to it.
I think I have an equation.
And then this should equal to the number of columns.
okay, I'm gonna tell you that he's correct,
I do have an equation.
okay? So Rahat is definitely on the right track. I think there's some things that we can tighten up a little bit. Yeah, Steve?
Y equals 0.75x plus 12.
Yeah. So those are gonna be the things that we tighten up. I'm gonna take this, because this is our 75 cents, right? That's how much we're timesing it by. What letter, well, I guess it's on the x-axis, so we'll refer to it as that. So the cost of the pizza is gonna equal 0.75, and we're gonna times that by the number of toppings. But there's a flat rate, because if I times 3 by 75, if I take a 3-topping pizza and times it by 0.75, I'm gonna get how much? $2.50, so $2.25? Well, $2.25 isn't $14.25. You have to add the 12 because that's the cost when there's no toppings on the pizza. No matter what pizza you order, it's going to start at a value of 12. So let's say, let C equal cost of pizza, and let N equal number of toppings. And so this is where I am. So we've created that equation. So if I substitute in 5 in for the number of toppings N, and we do that actual math, we should get $15.75 as our cost of the pizza. Okay, so if that pattern is consistent, if that pattern's the same all the way through your chart, that's the constant change, and that will give us a straight line data. Everybody get that copied down? Are we good to go on to the next one? All right. Okay, identifying the pattern. The cost of the rental car is $60 plus $20 for every 100 kilometers driven. So just by renting the car, and even if you go nowhere, you still have to pay $60 because that car is rented out to you under your name. Whether you choose to drive it or not is up to you. And then $20. So let's look at what's happening here. What's happening on this side? What's increasing? What's it increasing by? By how much? 20. And that is the same all the way through. But what's happening on the other side? What's happening in our independent data? Increases by 100. So you're seeing a consistent pattern on both sides. So if we were to create an equation for this one, what would it be?
Oh, I had one in my head.
Okay.
No, I can't remember.
All right. Well, what's our constant rate? What's happening here?
60
What's happening here?
plus 20.
Okay. 20 every what? Every 100 kilometers, right? So we're going to say that the cost is equal to $20. And I'm going to say over here, I'm going to say let D equal number of 100 kilometers traveled. So they only give you increments of 100. So if you drive 101 kilometers, Guess what they're going to charge you for? 200 kilometers. Because the increments are only in 100. So you go up by hundreds, right? So if you're over 100, where are you? You're in your next increment. If you drive 150, what are you going to be charged? 200. If you drive 199 kilometers, 200. And then what is the charge if I drive no kilometers? This is 0. If I drive no kilometers, what's that base charge? I'm circling it with my pen. Thank you. Oh, and I guess I should say, let's see, equal cost. Define both my variables. So I'm going to tell you what each variable means. Let D equal number of 100 kilometers traveled, because we're only doing them in 100 kilometer chunks. And C is going to equal the cost. Are you guys good if I flip the page? Perfect. All right. Okay, what's happening here?
It's linear relation.
How do you know?
I know that because we can see that they're all going up in a steady pace, so our domain is going up by 100, and
Okay.
our range is going up by 20. Hold on, 20, yes.
Do you guys recognize this data? It's the one from the previous page. It's just given as coordinate pairs. Do you guys find it easier to see as coordinate pairs or as a table of values? I think table of values, like that's what I tend to like to see. You can always put coordinate pairs as a table of values if you can't see the pattern. But the top ones are just looking at the independent variables, so that x value, whatever on the x-axis, and those are all increasing by 100. And then the bottom arrows are looking at the y values. Okay. Which table represents a linear function? Easiest thing to do is start looking at what the difference is between the numbers. So from here to here is 9. From here to here is also 9. This is 9. And that's 9. We have to make sure there's a pattern on the other side as well, though. So this goes up by 5s. This goes up by 5s. This goes up by 5s. And that goes up by 5s. Is there a consistent pattern? The answer is yes. There is a consistent pattern here. So if there's a consistent pattern in both your independent and dependent variables, this is a linear relation. Okay, let's look at the other one. So this one goes up by 75 here, and then it jumps to 225, and then 375, and then 525. Where does it go up by 150s?
The value that is added goes up by 150.
Well, from
Every
here.
time it goes up, the value that is added gets more.
Oh, I see what you mean, Steven. So
You add more every time.
Yeah, so you mean like the first time you're increasing up.
Oh, okay, so you're adding 150 to each one of these previous numbers.
Yeah,
Is that a consistent pattern?
No.
No. So even though there's a consistent pattern on this side, there's not a consistent pattern on this side. So this is not a linear relation. Okay. What's the easiest way to do this? Maybe I'll give you guys graphing calculators. I think that's probably the easiest. We can graph all of these.
Miss Callan, can you just use tables -2, -1, 0, 1, 2?
Sure, but we can also use the graphing calculator. That would be a visual representation. So I'm going to get you guys, I think most of these have batteries in them. You guys should be good. So if everybody can come grab a graphing calculator. I took out all the dead batteries.
No, I know what I got.
Thank you, Stan.
Just make sure your calculators turn on. All right. Okay, we're going to challenge ourselves and use some technology here. So when I graph a linear relation, what does it result in? What does it look like? It's a straight line, right? So when we graph these, we're going to decide if it's a linear function or not. Okay, everybody got their graphing calculator? All right, so we're going to hit y equals. Do you guys have your plot 1? Is it still dark on the top? We want to turn that off. So we're going to scroll up to your plot 1 is blinking. And we're going to hit enter just to turn it off. And then we're going to scroll back down to y1. Okay, we're going to put the first equation in there. So we're going to put in, and don't forget you got to use the negative sign, -3, and then the x is right next door to the alpha key. So we're going to put in x, and then that is add 25. Okay, does everybody have that one? Add that in. If you use the subtraction button, it's going to kick you out, and it's going to say there's an error. So you have to use that negative button that's located right at the bottom. Okay. Oh, I'm like right under the lights of this thing. Okay, we're going to hit the graph button. And you'll see that mine doesn't show anything because I have a weird window on. So I'm going to hit the zoom button. And I'm going to hit option 0, which is zoom fit. Option 0 is zoom fit.
Miss Callan, I can't find the expression on my
Pardon?
I can't find
It's
it.
next to your alpha.
It's right next door to your alpha button.
Next to alpha.
Got it.
Good.
Okay, so is this equation a linear relation? I'm going to turn off your plot. There you go. Okay. All right, is this a linear relation? Is it a straight line?
Yeah.
Yes, so this one is. What did you do?
I don't know. Everything was supposed to be fun and games, but
What'd you do about it?
I got a mountain.
You got a mountain?
I got Mount Everest.
There you go. So Rahatz was zooming in weirdly. So all I did was check what my window looked like, and I just entered that same window into his calculator. So if yours looks different than your friend's, chances are you're looking at through a different window. Okay? So if you hit that window button, you see all the things that I have. It doesn't have to be exactly the same as mine, but I think the more important part is that you see it. You see that entire graph. So we have decided that this one is linear. Okay, let's pop down to number 3 here. Let's pop down to number 3 just because I can see it. We're going to graph that one. So I'm going to go back to y equals, and I'm going to hit my clear button, and it's going to take that away. So you're going to hit clear, and it's going to go away. Y equals 5. You're in the list. You need to go to y equals. Okay, y equals 5. And then I'm going to hit the graph button. And I get this funky line.
Why is it saying invalid then?
Because you have something going on that's weird.
Error window range. Same thing with you, man.
Okay.
I told you.
Hi.
Yeah,
I'm trying to help.
distracting.
Okay, you still have your stat plot on, so that's screwing everything up. Turn your stat plot off.
How do I do that?
So when you're in your y equals,
Can you change the window to yours?
I don't think this window's great. I'm gonna, ooh, that's a big one.
Yeah, I don't know what I went to.
I did -10 to +10, so you get a better. Okay, let's do this again for turning your stat plot off. So if you're having a dim error, so let's go zoom and then go 6. You're just looking at the wrong window. That's all. Okay, so to turn off your stat plot, one of these will be dark. Your plot 1 will be dark. So if your plot 1 is dark, you're going to end up with, it's trying to graph the line and all the stuff you have in the tables. And it's having a hard time. You're getting a dimension error because your window isn't working for both sets of data. So you just got to go, you scroll up till the plot 1's blinking, hit enter, and then you can scroll back down. So now you see all my plots, plots are from the table. That's just turned off. So now the calculator knows, hey, I'm just focusing on the equations this lady's putting in here. So I go to graph. If you're not seeing that, zoom, and then option 6, the standard one, that's -10, +10, -10, +10 for the window. That's what standard is. So is that a linear function? Is that a straight line?
Yes.
Yes. So that one's linear. Okay. I'm going over to this one here. We're going to go over to B. All right, so back to your y equals. And we're going to go 2x. Now we need to make that a squared, an x squared. So you're going to either use the x squared button or you'll use the exponent button here. So either the x squared, that's diagonal from the 7, or the little exponent button above the division sign. And then it was +5. And now I'm going to graph that. Okay, so that's not a great window. I think I'm going to change my window. I want to see more of the top and less of the bottom. So I'm going to say my y is only going to go to -5. And my y max, let's go to 30. And if I say graph that. There we go. That looks a little better. So if you want to see my window again, that's what my window looks like. So my x's are -10 to +10. And my y's are -5 to +30. Using technology to help you graph to see if something's right is a really good strategy. I wouldn't recommend that you only use technology, because if you don't know how to do it by hand, you're really going to struggle. And if you want to go into pre-cal, we don't use our calculators a ton, although I do recommend that my grade 11s and 12s check their math on a calculator or online using Desmos. Okay, so there's my graph. Linear? Yeah.
No.
You need to have the plot off the whole time. No plots. No plots. This is not a straight line, right? So this one is no. Okay, for the next one, we have a problem. So for part D, it's x equals 1. If I go into the y equals, what do all these start with? What do they all start with? Y equals. What does my equation have? Okay, so there's no way to change that. There's no way to change that. So now we can use a table of values here. So let's look at this. All right, so if I were to do a table of values, what are my x's? What does the equation say? X equals 1. So what are all my x values? 1. Does it matter what the y values are? No, they doesn't matter. Oh, I shouldn't have done that. I should add another 1 in there, just so I get 5 points. So now, using a table of values, we can use our graphing calculator to graph this. So we're going to have to clear out your y equals while you're here, if you have your y equals sign open, so clear it. Okay. Now we're going to go into our stat, and we're going to go option 1. So stat is to the left of the cursors. So stat, and then option 1. So I'm just going to hit enter. Oh, I forgot to clear my list. It's okay. I can just delete them. So I have a delete key right here. There's not that much stuff in them. So I can just delete, go over to my list 2. I'm going to delete. Okay, I'm going to go back to list 1. What's in list 1? List 1 is all of my x values. So 1, enter, 1, enter, 1, enter. I have 5 in there. So that's 5. Okay, in list 2, I'm going to put -2, and remember you got to use the negative key, not the subtraction sign. Enter, -1, enter, 0, enter, +1, enter, 2, enter. So those lists should match up. You should have the same number in list 1 as you do in list 2. We good? Are we connecting the points? The answer is yes. We're going to connect the points because we don't know anything what we're measuring here. So we're going to go second function and y equals. And we're going to go to stat plot 1. You see that it's turned off because I already turned it off. I'm going to turn it back on. Second function y equals. And you're going to make sure that it's on. So you're just going to hit enter over the word on. And then we're going to make sure that we are connected in the type. So you see the blinking one is, the first one is discrete data, and the next one is continuous. So you want that one turned on. Mine just happens to be that already. Okay, you ready? We're going to graph it now. So we're just going to hit the graph button. Oops. Sorry, it's hard to see. It's because my window, so I'm going to go zoom and I'm going to go option 0. Oh, that did it too.
Should we ask a couple questions? Mine keeps saying window range error.
Yep. Yes, because look at this. So you're saying the lowest you're going to go is -5, and then you're saying the highest you're going to go is -30. Right, so -5, and then you're saying higher than that is -30, which isn't correct. So that's what the problem is. So if you change that to a +30 and then graph, you get it.
Thank you.
Okay? All right. Is this a linear graph? Is this a linear relation? Yes, it is. All right. Graphing calculators, magical. Once you get the hang of it, it's not bad, but it does take some getting used to. Okay, I am going to, are we good to flip the page? Yeah? All right. All right. A new car was purchased for $24,000, and every year the value of the car decreases by 15%. Okay? So, what are the two things that I'm looking for? What are the two things that are connected? We're looking for value related to time. So which one is our independent and which one is our dependent? So now you're using all your skills to put everything together.
Time would be independent.
Time would be independent. Good call. Okay, so T and V over here. So obviously, if time is independent, that means our value is dependent. So the value of the car is dependent on how long you've owned it. Okay, so at 0 years, I haven't even owned it for a year. Today's the first day I bought it. How much is it worth? How much is it worth? I just paid for it. $24,000. This is a tiny table. We're going to have to write outside the table. Okay. So now I've owned it for a year. How much is my car worth? Is it worth more or less? Let's start there.
It's worth 3,600 less every year.
Nope. Not every year. Okay. Okay. So where'd you get the 3,600 from, Steve? Because I think you're on the right track.
Dividing by 10, divided by 5, running those two together. 15%.
Okay, so you took 10% of 2,400, and then you took 5% of that?
24,000. Yeah.
Okay.
600 decrease every year.
So I think what Steve did was essentially you took the 24,000 and you times it by 0.15, and you got, whoo, I'm still graphing. I got the 3,600, right? Is that what the car's worth? Is the car worth $3,600? No. How much is the car worth? Well, it was worth 24,000, so after a year, the car decreases by 15%. This is a hard one. People, it's definitely a hard concept to get. So if we're decreasing, this is the amount we're taking off the price, right? You guys would agree with me? So this is going to be the 24,000 minus 3,600. Yeah?
Miss Caroline?
What?
I just have a question. Since we're decreasing 3,600, then the value of the car is going down. So then the car is not worth $2,400, $22,000 anymore. So that means 15% of 20,000.
Yeah. That was very panicked. That was very panicked. I thought maybe you were having a heart attack there, but you all good? Okay. Okay. All right. So if I take 3,600 away from 24,000, I get 20,400. So after 1 year, my car is worth, it's not worth 24,000 anymore. It's worth $20,400. Okay. In my second year of owning the car. Do I take the 15% off what it was originally, or do I take the 15% off what it was, the value of it at year one? At year one. Okay? At year one. So we can do it one of two ways. So we can keep going like this. We can go 20,400 times by 0.15 and get that, and we can do a subtraction. But here's my question to you. There's an easier way to do this. If it's decreasing by 15%, how much is it worth? How much is left over? What are percents measured out of? 100. So if it's decreasing by 15, what's left? 85. So it's worth 85% that it was the year before. Does that make sense to everybody? Sorta, kinda? Sorta, kinda. So this bar represents 100%. How much gets cut off every year? 15% gets cut off. 15%, we take that off. What's left of this bar? 85%. So the value of the car is 85% of what it was last year. So you can still do it this way where we're subtracting, like we're taking that 15% and we're cutting it off the price. So 20,400 times by 0.15, 3,060. And so I'm going to take 20,400 minus 3,060. And I get $17,340. So that would be after year 2. Another way I could do it though, just let me switch colors for a sec. Another way I could do it is I could take 20,400 and I can times it by 0.85 because that's what we have left over. And if I do that, 20,400 times 0.85, I get the exact same answer. So here we did it in 2 steps where we were like figuring it out and then taking it away. Or you could see what's left over and multiply that in. It really is what makes the most sense to you. Doing it this way is kind of handy because doing it the 2-step way, because we know from here to here this is 3,600. We know from here to here this is 3,060. I don't get that. I'd have to subtract that. Okay, so you guys do the next 2 values, 3 and 4. I'm going to hit pause because I'm going to do them, and then we're both going to check our answers. You guys have to do 2, and I'm okay with whatever way you want to do it.
Can I use water?
No.
It's very important right now.
Is it? Because you're sitting there and you're laughing and going on, and I don't know what music you're listening to, but you're not doing this.
I use the washroom.
Okay, then if you gotta go, go.
Go for a jog.
Okay, I got some more information about the pep rally tomorrow. The pep rally, so D block is going to finish a little bit early tomorrow, so we gotta get in here and get our rate of change done, so if you guys can be on time, that would be swell. And then you guys need to check with your E block teachers if they want you to, if they're going to the pep rally in E, then you can stay in the pep rally, but if not, you gotta go to your E block class, and that's up to the teacher to decide. Okay, can I show you my chart?
No.
Okay,
No, 1 second, please.
okay.
Okay.
Can I show you now?
No.
Yeah.
Still no? Okay.
Yep.
Yeah.
Yeah.
Are you sure, Jonah? Okay. Did you guys get those?
Yeah.
Yeah? So now my question is this a linear relationship? No, because are these following the same amount every time? So this is not, so it's not a linear relation, because even though these are going up by ones every time, those are going up by ones, the other side isn't going up by ones. Okay, part B. Part B. Okay, for a service call, an electrician charges $75 flat rate, and then $50 an hour for every hour that they work. The total cost of the service is related to time. Okay, so we have cost and we have time. Which one is independent and which one is dependent? Yeah. Time is independent. Because the guy's going to charge you a certain amount based on how long he's at your house fixing your wiring or whatever he's doing there. So your time is independent. So T for time and C for cost. Okay, so I did this once. I had to call an electrician because my stove wasn't working.
You didn't check behind the stove, see if it was unplugged?
Yeah, there you go. So called the electrician to the house. And so the call out fee, even though I had figured it out by the time he got to my house, he still charged me for getting called out. So if he works, I'm saying he, but it could be a she or they, if they work no hours in your house, how much are they charging you? $75. Okay, let's say it's not a silly problem like I had. It was a real problem, and they worked 1 hour. How much are they going to charge me? Mental math. 125. And if they worked 2 hours, $175. And if they work 3 hours, are you sure $225? Okay, just making sure. And if it was a really big job and they had to spend 4 hours at my house, $275. Oh geez. Now we're in competition to see who says it faster. Okay, so the change from here to here was 50. The change from here to here is 50. The change from here to here is 50. And the change from here to here is 50. 1, 1, 1, 1. Is this a linear relation? Yes, yes it is, because the pattern increases by the same amount on both sides. Or sorry, there's a pattern of increasing on both sides. So this one is, yes, it is a linear relation on this one. Okay, that's it, that's all. Easy peasy.